You think you understand speed, step on the gas, go faster, floor it, faster still, more power, more velocity, no ceiling, no wall, no limit, just you, the machine, and the open road, until there isn't. 299, 792 forward and 58 meters per second. Not a speed limit like the ones on highways, not a technical barrier we haven't overcome yet, not something that better engineering will solve. This is different. This is the universe itself saying, this far, no further. And here's the secret that will haunt you once you understand it. The speed of light has absolutely nothing to do with light. Light just happens to move at this speed. The speed itself, that's something far stranger, far deeper, far more fundamental to the fabric of reality than most people ever realize. This is the speed of causality itself, the speed at which propagates through space, the maximum rate at which anything can influence anything else. It is not imposed on the universe, it is the universe. And once you see why, truly see why, your intuition about time, space, and motion will never recover. Let me show you. Part-eyed the fall that united heaven and earth. We start somewhere you've been 1,000 times. Standing on solid ground, holding something in your hand, a stone, a coin, your keys. Open your hand, watch it fall. After 1 second, that object has dropped approximately 4.9 meters. After 2 seconds, 19.6 meters. The acceleration is constant 9.8 meters per second. This seems obvious now, mundane even. But for most of human history, nobody understood why things fall. Aristotle thought heavy objects fell faster than light ones. It seemed intuitive, drop a rock and a feather, and the rock hits first. Case closed. For nearly 2,000 years, this satisfied everyone. Then Galileo did something radical. He actually tested it, not with thought experiments, not with philosophical reasoning, with ramps, spheres, and measurement. And he discovered something that shattered intuition. All objects fall at the same rate. The feather falls slower not because it's lighter, but because air resistance affects it more. Remove the air, create a vacuum, and the feather and the rock hit the ground simultaneously. Mass doesn't matter. Material doesn't matter. Composition doesn't matter. Gravity treats everything equally. This was humanity's first glimpse of something profound. The universe follows mathematical laws that don't care about our intuitions. But Galileo only solved half the puzzle. He told us how things fall. He didn't tell us why. Now look up. The moon hangs in the sky 400 kilometers away. It's not falling. Or is it? Here's a thought experiment that changes everything. Imagine the moon suddenly stopped moving sideways, just froze in its orbital path. What would happen? It would plummet toward Earth like a stone. The only reason it doesn't crash into us is because it's moving sideways fast enough to continuously miss the planet. An orbit isn't balance. It isn't suspension. It isn't some special state. An orbit is perpetual falling. The moon is falling toward Earth right now, at this exact moment, as you read this. But it's also moving sideways at 83 kilometers per hour, and that forward motion means it keeps falling around Earth instead of into it. Isaac Newton saw this and asked a question that nobody had dared to formalize mathematically. What if the force pulling the apple to the ground is the exact same force pulling the moon toward Earth? Not similar, not analogous, identical. The same force, just weaker because the moon is farther away. But how much weaker? Newton proposed the inverse square law. Gravity weakens with the square of distance. Double the distance. 1/4 the strength. Triple the distance. 1/9 the strength. The moon sits about 60 times farther from Earth's center than we do on the surface. So gravity at the moon's distance should be 600 times weaker. On Earth's surface, objects fall 4.9 meters in the first second. So at the moon's distance, something should fall about 493,636 meters per second, about 136 millimeters per second. When Newton calculated how far the moon actually deviates from a straight line per second, how much it falls toward Earth while orbiting, he got 136 millimeters. Exact match. Read that again. An apple falling in an orchard and the moon circling overhead, two phenomena that seemed completely unrelated, were suddenly revealed to be the same thing. One equation, one force, one law. This wasn't philosophy. This wasn't speculation. This was mathematics agreeing with reality to absurd precision. Newton had unified heaven and earth. But he didn't stop there. If gravity follows this inverse square law, then what kind of paths should planets trace as they orbit the sun? The mathematics gave an answer: ellipses. Johannes Kepler had already observed this empirically, meticulously plotting planetary positions for decades. But he didn't know why planets moved in ellipses. Newton's law explained it instantly. One law, multiple mysteries solved. Then came the tides. People had noticed that ocean water rises twice per day, not once. Why two high tides instead of one? Newton showed that gravity isn't uniform across Earth's diameter. The moon pulls more strongly on the side of Earth facing it, and less strongly on the far side. This creates two bulges in the oceans, one facing the moon, one on the opposite side, two bulges. Two daily high tides. The moon's gravity also explained why Earth bulges slightly at the equator, why the moon always shows the same face toward Earth, why Jupiter has captured more than 90 moons, why Saturn's rings don't collapse into the planet. Gravity wasn't just a force. It was a unifying principle that connected phenomena across every scale. And here's what matters for our story. Once you find a law that explains everything, you don't abandon it lightly. When anomalies appear, and they always do, you don't throw out the entire framework. You trust the pattern. You dig deeper. You ask what else might be at play. This principle, this scientific instinct, is about to reveal something nobody expected. Part I, the anomaly that shattered infinity. The year is 1676. Rømer, a Danish astronomer, is obsessively watching Jupiter's moons. Jupiter has 4 large moons, Europa, Ganymede, and Callisto, discovered by Galileo in 1610. They orbit Jupiter like clockwork, disappearing behind the giant planet and emerging on the other side with metronomic regularity. The innermost large moon completes one orbit every 5 hours. You could set your watch by it, except you couldn't. Sometimes I emerged from behind Jupiter earlier than predicted. Sometimes later. The difference could be as much as 8 minutes. 8 minutes is an eternity in astronomical precision. These weren't small measurement errors. These were massive, systematic discrepancies. Something was profoundly wrong. Rømer could have blamed Jupiter. He could have blamed his instruments. He could have questioned Newton's laws of motion and gravity, which were still relatively new. But Rømer noticed something crucial. The discrepancies had a pattern. When Earth was closest to Jupiter in its orbit, Io appeared early, emerging from Jupiter's shadow ahead of schedule. When Earth was farthest from Jupiter, Io appeared late, emerging behind schedule. The timing error correlated perfectly with Earth's distance from Jupiter. And then Rømer had a realization that changed physics forever. What if light takes time to travel? When Earth is closer to Jupiter, we see events sooner because light has less distance to cover. When Earth is farther from Jupiter, about 300 million kilometers farther, roughly twice Earth's distance from the Sun, light takes longer to reach us, so we see the same events delayed. The round-trip difference in Earth-Jupiter distance is about 600 million kilometers. The time difference in observations about 16 minutes round trip or 8 minutes one way. From this, Rømer calculated that light must travel at approximately 220,000 kilometers per second. The modern precise value is 299,792 kilometers per second. Rømer was remarkably close, given the crude instruments of the 1670s. But here's what matters. Rømer had proven that light is not instantaneous. For all of human history, people assumed that sight was instant. You open your eyes and you see no delay, no gap. Suddenly, that was wrong. Light moves. It has a speed. It takes time to cross space. When you look at the moon, you're seeing it as it was 3 seconds ago. The sun, 8 minutes and 20 seconds ago. The nearest star, Proxima Centauri, 424 years ago. The Andromeda Galaxy, 5 million years ago. Some of the light entering your eyes left its source before your species existed. You have never seen the universe as it is. You have only ever seen the past. The present, the true now, is forever inaccessible. By the time light carries information to you, that information is already old. And this realization, this limitation, is about to become far stranger than anyone imagined. Part II, the experiment that murdered common sense. Let's do a simple thought experiment. You're standing on a train platform, holding a flashlight. You turn it on and measure the speed of the light beam traveling away from you. Result 299,792,458 meters per second. Now you board a train moving at 100,000 kilometers per second, about 1/3 the speed of light. Absurdly fast by everyday standards, but perfectly reasonable for our thought experiment. You stand on this moving train and shine your flashlight forward. in the direction the train is traveling. Question: how fast is the light moving relative to the ground? Common sense gives an immediate answer. The light is moving at 299, 792 km. The train is moving at 100,000 km. So the light beam is moving at 399, 792 km relative to the ground. Velocities add, they always add. If you throw a baseball forward from a moving car at 100 km and the car is moving at 80 km, the ball moves at 180 km relative to the ground. This is obvious. This is intuitive. This is how motion works. Except when you actually measure the light from the moving train, you get 299 mas. Exactly the same. Maybe you measured wrong, you think, so you speed up the train. Now it's moving at 200,000 km/s, 2/3 the speed of light. Measure again, 2999, 792, 458 mph, still the same. Fine. Get the train moving at 99% the speed of light, then 99.999%, then 999.99%. At every speed you measure the light beam, and every single time you get the same result, 299.792,458 meters per second. The light beam doesn't care how fast you're moving. It moves away from you at exactly the same speed whether you're standing still or screaming through space at 99.999% of light speed. This isn't a rounding error. This isn't measurement uncertainty. This isn't approximation. This has been tested thousands of times with absurd precision. The Michelson-Morley experiment in 1887. Particle accelerators in the modern era. GPS satellites orbiting Earth right now. Every test confirms the same impossible truth. The speed of light is constant for all observers, regardless of their motion. And this single fact, this one piece of data, obliterates the entire structure of classical physics. Part IV, the price reality pays for constancy. Albert Einstein stared at this impossibility for years. If light always moves at the same speed for everyone, regardless of how fast they're moving, then what gives? Something has to be flexible. Something has to change to make the mathematics work. Speed is defined as speed to distance, time, if speed must remain constant. But different observers are moving at different velocities, then distance and time must change, not appear to change, not seem to change, actually change. This is the core of special relativity, published by Einstein in 1905. Time dilation, moving clocks tick slower than stationary ones, not because they're broken, not because motion damages the mechanism, but because time itself flows more slowly for objects in motion. In 1971, physicists performed the Hafel-Keating experiment. They put atomic clocks on commercial airplanes, flew them around the world, and compared them to identical atomic clocks that stayed on the ground. The traveling clocks were slower by exactly the amount relativity predicted, mere billionths of a second, but measurable, undeniable, real. GPS satellites orbit Earth about 14,000 kilometers per hour. At that speed, their clocks run approximately 7 microseconds slower per day than clocks on Earth's surface. 7 microseconds. A fantastically tiny amount, but light travels 300 meters in 1 microsecond. If GPS didn't account for time dilation, your phone's navigation would drift by multiple kilometers per day. Within a week, it would be useless. The reason GPS works, the reason you can navigate to an address with meter-level precision, is because engineers programmed the satellites to account for Einstein's equations. Your smartphone is proof that time dilation is real. Length contraction distances shrink in the direction of motion. From the perspective of a particle moving at 99.9% the speed of light, the entire 27-kilometer circumference of the Large Hadron Collider compresses to less than 2 kilometers. The particle thinks it's traveling a much shorter distance. We think it's moving incredibly fast. Both perspectives are correct. Both are equally real. Space and time warp by exactly the right amounts, in exactly the right ways, to ensure that the speed of light remains constant for everyone. The universe bends reality itself to protect the speed. But why? Why does the universe care so much about keeping the speed of light constant? Part V, the wall that cannot be broken. Here's where things get truly unsettling. You want to accelerate a spacecraft to the speed of light. You fire the engines. The ship speeds up, more thrust, faster still. At 10% light speed, everything feels normal. At 50% light speed, you're moving faster than anything humanity has ever built. At 90% light speed, you're in uncharted territory. But something strange is happening. The ship is becoming harder to accelerate. You add more fuel, more energy, more thrust. The ship speeds up, but less than it should. At 90% light speed, your effective mass, your resistance to acceleration, has increased to about 2. At 99% light speed, 7 times your rest mass. At 99, 9%, 20, so 99, 99%, 70 times, and 99, 999%, 7 or 7 times. The closer you get to light speed, the harder it becomes to accelerate. And it's not linear, it's exponential. At 99, 999,999% the speed of light, you'd need to pump in energy equivalent to the mass energy of an entire planet just to nudge a tiny bit faster. At exactly light speed. Infinite energy required. Not a lot of energy. Not more energy than currently exists in the universe. Undefined. Impossible. This is not an engineering challenge. This is not a fuel problem. This is not about building better rockets. This is reality itself saying, no. The universe has a hard limit, and it enforces that limit through the very structure of space-time. Why? Part VI, what the speed of light actually is. Here's the moment everything clicks into place. Ready? The speed of light is not the speed of light. Let me say that again. The speed of light 299,792,458 MBLS is not fundamentally about light. It's the speed of causality, the maximum rate at which cause can produce effect, the maximum speed at which information can travel. The cosmic speed limit for anything that can influence anything else. Light happens to move at this speed because photons have zero rest mass. Massless particles have no resistance to acceleration. They don't gradually speed up. They are instantly at maximum speed the moment they're created, and they can't slow down. A photon in a vacuum always moves at exactly c, the speed of light from the moment of emission to the moment of absorption. But the speed itself, that 299,792,458 meters figure, that's a property of space-time, not a property of light. Let me show you why with a concept that will rewire your brain. You are always moving through space-time at the speed of light. Read that again. Right now, sitting still, you are moving through space-time at exactly the speed of light, not through space. Through space-time, space-time has 4 dimensions, 3 of space and 1 of time. Your total motion through these 4 dimensions is always constant, always light speed. Right now, sitting still in space, all of your motion is directed through the time dimension. You are moving through time at 1 second per second. Now imagine you start moving through space. You get up, you walk, you drive, you fly. As you move faster through space, something has to give. Your total motion through space-time is constant. So if you're now moving through space, less of your motion can be through time. Moving through space makes you move more slowly through time. This is time dilation. It's not a side effect. It's not a correction. It's the fundamental geometry of space-time. At 87% the speed of light, your motion is split roughly 50-50 between space and time. You experience time at half the normal rate. At 99.5% the speed of light, almost all your motion is through space and very little through time. 1 year for you is 10 years for someone standing still. At exactly the speed of light, which only massless particles can achieve, all motion is through space, and none through time. Time stops. From a photon's reference frame, emission and absorption happen at the same instant. No journey, no duration, no experience of time. A photon emitted by a star 10 billion light years away experiences 0 time during its journey. From its perspective, it is created and destroyed in the same moment. And here's the kicker. You cannot go faster than light because that would require moving backward through time. It would mean having negative temporal motion, effects before causes, receiving messages before they're sent, outcomes preceding decisions. The universe treats this as a logical contradiction and forbids it absolutely, not through force, not through barriers, through geometry. The structure of space-time itself makes faster than light travel equivalent to time travel, and time travel equivalent to paradox. Reality doesn't allow paradoxes. Part theory, the unanswerable question. So why is the speed of light exactly 299,792,458 MIVAS? Why that number and not some other? Here's the most honest answer physics has. We don't know. The speed of light is a fundamental constant of nature, like the gravitational constant, the charge of an electron, or Planck's constant. These numbers define what kind of universe we inhabit. If the speed of light were significantly faster, the universe would be a very different place. Stars would burn differently. Atoms would have different energy levels. Chemistry would change. The conditions for life might not exist. If it were significantly slower, the electromagnetic force would behave differently. The universe might have collapsed back into itself before galaxies could form. But why these specific values? We can measure them. We can verify them. We can use them to make predictions with extraordinary precision. But we cannot explain why they have the values they do. And maybe that's okay. Science doesn't demand absolute, final answers to make progress. It demands that we ask better questions, that we test our ideas against reality, that we follow the evidence, especially when it contradicts our intuitions. Part B, the technology built on broken intuition. These aren't just abstract ideas. These impossible truths power the modern world. GPS satellites must correct for both special relativity and general relativity. Without these corrections, without accepting that time runs differently in orbit, GPS would fail within minutes. Particle accelerators slam protons together at 99.99991% the speed of light. The proton's effective mass increases by a factor of more than 7,000. The engineers who designed these machines use relativistic equations for every calculation. If relativity were wrong, the Large Hadron Collider wouldn't work. We wouldn't have discovered the Higgs boson. Particle physics would be impossible. Nuclear power and nuclear weapons rely on e-dial, the equivalence of mass and energy that comes directly from relativity. Medical PET scans use positron emission, which requires understanding antimatter, a prediction of relativistic quantum mechanics. The entire telecommunications industry is built on electromagnetic wave propagation at light speed. We have constructed a global technological civilization on top of these truths. Not because they're intuitive, not because they're comfortable, because they're correct, and the universe doesn't care whether we're comfortable. Part IX, the avalanche of understanding. None of this was obvious. 400 years ago, Galileo rolled balls down ramps and discovered that acceleration is constant. Isaac Newton saw that apples and moons fall the same way and unified heaven and earth with one law. Rømer watched Jupiter's moons and realized light has a speed. James Clerk Maxwell unified electricity and magnetism and discovered that electromagnetic waves must travel at a specific speed, which happened to match the measured speed of light. Albert Einstein realized that if light speed is constant for all observers, then space and time must be flexible. Each insight unlocked the next. Each discovery became a foundation. Each truth became a tool to find deeper truths. This is how science works, not through revelation, not through authority, not through intuition, through observation, measurement, prediction, and relentless testing. And the pattern continues. Einstein's general relativity predicted that massive objects warp spacetime, causing light to bend. Arthur Eddington observed this during a solar eclipse in 1919. Relativity predicted that time runs slower in stronger gravitational fields. We've measured this. Clocks at different altitudes tick at different rates. Relativity predicted gravitational waves, ripples in spacetime itself. LIGO detected them in 2015, more than a century after Einstein's prediction. Every test confirms the same story. The speed of light isn't a suggestion. It's not a guideline. It's enforced by the deepest structure of reality. Part X, the beauty in the breaking. Let's bring it all home. Why can't anything go faster than light? Because spacetime has a geometry, and that geometry contains a maximum rate at which causality can propagate. That rate is 299,792,458 meters per second. It's not imposed on reality, it is reality. It is the speed of information, the speed of influence, the speed at which know spreads through the universe, the maximum rate at which anything can affect anything else. Light moves at this speed not because light is special, but because massless particles have no choice. They reach maximum speed instantly and cannot deviate from it. But the speed limit itself is a property of space-time, and this understanding didn't appear overnight. It emerged from watching the moon, from timing Jupiter's shadows, from asking why velocities don't add the way they should, from following the mathematics even when it seemed insane. Each generation added a piece. Each insight revealed new questions. Each answer opened deeper mysteries. And we're still going. Quantum mechanics added another layer. Particles can be entangled, correlated in ways that seem to violate locality. But even quantum entanglement doesn't transmit information faster than light. The universe protects causality even in the quantum realm. We still don't know how to unify relativity with quantum mechanics. We still don't understand what dark matter is, or dark energy. We still don't know if our universe is one among many. The mysteries keep growing, but so does our understanding. The final truth, the speed of light, is not just a number. It's a message. It tells us that space and time are not separate, unchanging backdrops. They are woven together, dynamic, responsive. It tells us that mass and energy are equivalent, different manifestations of the same underlying reality. It tells us that causality has a speed limit, that the universe has structure, that reality obeys rules we can discover. And it tells us something even more profound. The universe is comprehensible, not easy, not simple, not comfortable, but knowable, through observation, through mathematics, through the courage to question everything we think we understand. We are pattern-finding creatures living in a universe that has patterns. And when you look up at the night sky and see starlight that left its source before your grandparents were born, you're not just seeing distant suns. You're seeing the geometry of space-time. You're seeing the limit that defines reality. You're seeing the deepest structure of existence. Not because it was handed to you, but because we extracted it from nature, one careful measurement at a time. That's the miracle. Not that the universe has rules, but that we, hairless apes on a small planet orbiting an average star, can discover them. The speed of light seemed like a barrier. It turned out to be a revelation, and the fact that it breaks our intuition, that it violates common sense, that it forces us to abandon our everyday assumptions about time and space. That's not a bug. That's the entire point. The universe doesn't owe us comfort. It doesn't owe us simplicity. It doesn't owe us intuition. But when we ask the right questions, when we measure carefully, when we trust the mathematics, when we follow the evidence wherever it leads, no matter how strange, the universe tells us the truth. And the truth is wilder, stranger, and more beautiful than we ever dared imagine. Welcome to reality. It's weirder than you thought. And that's exactly why it's worth understanding.